And no, Chris, you are not allowed to have a personalized background.
Oh, why not?
Because it's just doesn't fit in with the format. Hello, and welcome back to Physics Chat. My name is Susanna, and I'm back with my lovely co-hosts, Sergi and Molly, ready to do some more chatting. You may remember Molly from our first YouTube video where she was interviewed about her research. And if you've been following our Instagram, you will know she is also part of the Field of View team. But today she joins us on the interview panel. Welcome back to Physics Chat, Molly. How are you doing?
I'm good, thank you. I'm excited to be on this side of Physics Chat.
Brilliant. It's great to have you back on the show. On today's show, we have Chris, a third-year PhD student at the University of Portsmouth. He is currently researching population 3 stars, which are the first stars to have formed after the Big Bang. Hello, Chris. How are you?
No, I'm very well, thank you.
Good. So, Chris, tell me, what do you do in your free time? Again, this is the part of the show where I just ask a random question.
In my free time, I play games. Do that too often, I think. I try to go to the gym as often as I can as well.
How often is often for you?
I aim for about 6 days a week, but it hasn't been working out that way recently, unfortunately.
And the most important question, how much can you lift?
Far less than you can.
Very true. Even though I don't go to the gym, but that is true.
So, Chris, sort of back to the physics, could you tell us a little bit about your journey into research?
Sure. So I started off doing my A-levels. I was doing chemistry, physics, biology, and maths. And unfortunately, I had to drop chemistry because I simply failed. I couldn't keep up with the workload. But after that, I decided that I wanted to do physics at university. So I did my undergraduate degree at the University of Portsmouth. Well, I was very interested in the astrophysics modules. And so I decided to apply for a PhD at the ICG.
Wow, that's really cool. So before you dropped chemistry, did you have a favourite element in the periodic table?
I do have a favourite element. If I had to go for one, I would pick tungsten, I think. It's the metal with the highest melting and boiling point.
Wow, that's really cool. When I heard that you were coming on Physics Chat, I thought I'd swap up a bit on my elements, and I learned that there's an element called lanthanum. I had no idea. That's used for telescope lenses. But anyway, back to you. Could you tell us a little bit about your research at the ICG? What are you doing at the moment?
So my research specifically is focused on the formation of population 3 stars and their supernova, modeling them and seeing their effects.
That sounds really cool. Could you just explain a little bit about what a star is, and specifically a population 3 star?
Mm-hmm. So a star is something like our sun. It's a hot ball of plasma. A population 3 star is the first generation of stars to form in the universe. So they were the first ones ever. And these were formed purely of hydrogen and helium. They're thought to be massive as well, but there's some uncertainty about that.
Okay, cool. So can we observe these population 3 stars, like to learn a bit more about them?
Unfortunately, no, we can't.
Wait, so if we can't observe them, how do we know they existed?
We don't know that they existed in the way that we think about it. Obviously, they had to have been the first star to form in the universe. It's just whether or not these stars that have formed actually had the properties that we think that they did. That's the question.
Okay, so the properties we're not that sure about, but they existed, and we know that, right?
Yeah, we know that there was a first star. But that's the limit of what we are actually able to understand fully.
Okay, makes sense. And you mentioned that you study these population 3 stars by modeling their supernova. So could you please explain what a supernova is?
Yeah, so as a star reaches the end of its lifetime, depending on how massive the star is, it will explode as a supernova. That's what a supernova is. It's an explosion at the end of a star's life. Okay,
and there's something there you said, depending on how massive they are. Is there a distinction between different types of supernova?
Yeah, so for population 3 stars, we're looking at either what's called a pair instability supernova or a core collapse supernova. So a pair instability supernova, firstly, is reserved for the very highest mass stars. So we're talking 130 solar masses and above. What happens in this case is in the core, it's at such a high temperature, you have these high energy gamma rays. And in some situations, these high energy gamma rays can be responsible for pair production of electron-positron pairs. When this happens, there's energy removed from the radiative pressure that keeps the envelope from collapsing in on itself. And when a cascade of this effect happens, you've got too much energy removed, which means that the envelope then just falls in on itself and you have an explosion. And this is the pair instability supernova. There is nothing left behind at this point, so the star is completely disintegrated. Now, a core collapse supernova is reserved for the lower mass end of stars, so 40 solar masses below. What happens is in the core, when you get to a point where iron has been made, you're no longer getting energy from fusion. So you have a dip in energy of this radiative pressure outwards that keeps the envelope from falling in on itself. And when this happens, the outside of the star falls in, crushes the core on the inside and rebounds outwards. And this rebound off the core is the supernova explosion. And usually this leaves behind a compact remnant like a neutron star.
For those watching, I'd like to say that Chris has a special guest has also appeared on his screen. That is Mr. Boy. There we go. Oh, look at him. This is a special appearance of Mr. Boy. He is an astrophysicist, isn't he?
He is, yeah. He's better than I am.
Amazing.
I'm just gonna be in the background here.
So, Mr. Boy, what's your research about, please? Let's see if I understood this correctly. So we have two types, the pair instability and core collapse supernova. The main difference between them is the mass of the star. So the pair instability are 130 and above. And because they're so massive, you have these pair instability processes happening at the core, which eventually lead to a very different end life of the star, right?
Mm-hmm. Yep.
Cool. So now for population 3 stars, how do these supernovas look like?
So I can actually show you. What I have for you here is a pair instability supernova simulation of a 180 solar mass population 3 star reaching the end of its life.
And what do you mean by simulation?
So a simulation is an imitation in a computer of a real life process. Specifically, what you're seeing here, you're looking at how heavy elements, when I say heavy elements, I mean metals, which includes everything heavier than helium, how these are released when a supernova occurs and how these metals interact with the surrounding environment. What you can specifically see is a massive increase in temperature as the star dies, and you've got this envelope expanding outwards, and that would be where the metals begin interacting with the surrounding environment.
So we have all these simulations that are telling us about the explosion of population 3 stars. But what question is there still to be answered in your research field?
Well, we don't know the mass range of these stars properly yet at the moment. There's a lot of uncertainty about how massive they can be or what the average population 3 star mass would be, for example. Now, it's possible that future telescopes might be able to answer this question if they can look further back in time, such as the James Webb Space Telescope.
Oh, wow. That is so interesting that your research has no photos or data, yet this is not a limit and you're pushing the boundary of our understanding despite that. So, Chris, thank you so much for being on the show and for sharing your fascinating research about population 3 stars.
Thank you for having me.
Well, we hope you've enjoyed today's discussion on stars, supernovae, and chemistry. I certainly have. Who would have thought that chemistry would be required in solving an astronomy question? It was inspiring hearing Chris's journey and how he ended up doing his research in astronomy and chemistry, even though he dropped out of chemistry.
Thanks for reminding me of my failures.
You're welcome. Molly, Sergi, and myself will be back for another physics chat. And let us know in the comments section what your favorite element is. I think mine would be hydrogen because the sun is currently burning it. But I'd love to hear yours, so keep writing. But for now, from everyone at Field of View, we hope you have a good day and goodbye.
Goodbye.
Bye. Thanks for reminding me of my failures.
So blah, 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 difference between... So what is the difference between these supernovas?
Now, in some situations, these high energy gamma rays cause pair production of electron-positron pairs.
Mm-hmm.
Is it electron-positron?
Mm-hmm.
Okay, just cut that bit.
That's going to go in a blooper. The person we're interviewing, asking us. I love it. Hello, Mr. Boy.
I've woken him up from his sleep. He was happily sleeping on my desk, and now I've ruined it. Look how angry he looks.
Yeah, a bit angry.
He's completely covered everything in hair.
That's what he thinks of your research.
He's not impressed. This is what happens when I wake him up from his sleep. He decides that, you know what, I'm going to get hair everywhere.
That is such a good... Aww. Thank
Isn't
you,
he
Mr.
handsome?
Boy, for
Say he's
being
handsome.
on. Yeah, he's very handsome. Thank you, Mr. Boy, for being on the show. We really appreciate you coming on. You were much better than our first guest. I feel like you're so good, so demanding of the screen. Yeah, exactly. You tell him. Oh, brilliant.